for this lab 4, first for this question 4.1, first calculate the transfer function based on the circuit in figure 1, which is RLC circuit. Then you need to change the inductor, resistor, and capacitor into S domain. And then multiply to K over S. After we gain the value of transfer function, and then next run the function using MATLAB software. Okay, so this is the function. For numerator 0.1, based on the value of K in the questions given, which is it state that use K equals to 0.1. Okay, so run the circuit, and here is the result 0.1. And then for denominator 4S3 plus 4S2 plus S. And here is the Bode diagram. Then we need to choose characteristic and all stability margins. And for the magnitude dB for this system, gain margin is 20 at frequency 0.5 radius, and this closed loop is stable. And for this system, the phase margin is 68.2 degree, delay margin 12.3 second, frequency 0.0964 rad. And the closed loop, and this closed loop is also stable. Okay, and then next we need to plot for for exercise 4.1, which is in figure 3. Calculate the transfer function in using this circuit figure 0.3, and then after you done calculating, by using MATLAB software, we complete this task 4.1.2. So it state here, the question said that K equals to 100. So we need to obtain margin in dB, phase margin, gain crossover frequency, phase crossover frequency, and then obtain the same Bode plot when K equals to 50, 500, and 1500. So first K equals to 100. K equals to 100. So this is my transfer function. And then numerator 300, 300, denominator 1, 57, 360, 500, and 0. Okay, then run. And here is the Bode diagram, characteristic or stability. And then for this system, the gain margin is 35 dB at frequency 17.5 rad. And then is the closed loop stable? Yes, it is. And for this system, the phase margin is 96.9 degree, delay margin 2.4 at second, at frequency it is 0.681 rad. And the closed loops is also stable. Next, for K equals to 50. This is here is what I got from the transfer function. So we need to run. Okay, run. And here is the Bode diagram. Characteristic or stability. For this system, the gain margin is 41 dB. For the gain margin in magnitude, which is dB, is 41. At frequency 17.5 rad. The closed loop is stable. And for this system, the phase margin 94.5 degree, delay margin 5.32 second, at frequency 0.31 rad, and the closed loop is also stable. Okay, next, K equals to 500. K equals to 500. Okay. This is my result, and then we run. So this is my transfer function, and then this is the Bode diagram. So that this system receive the gain margin for magnitude in dB is 21, at frequency 17.5 rad, and the closed loop is stable. And for phase, which is degree, the phase margin 56.9, delay margin 0.234 second, at frequency 4.24 rad, and the closed loop is also stable. And for K equals to 1500, the numerator is 4500, denominator 1, same as before, which is 157, 360, 500, and 0. And then, and then we need to run. And here is the transfer function. And this is the Bode diagram. Characteristic. So for the system, the gain margin is 11.5, at frequency 70.5, and the closed loop is stable. For this system, the phase margin is 26.5 degree, delay margin 0.0533 second, at frequency 8.68 rad, and the closed loop is also stable. Okay, this is all from me.